Welcome back, friends. In this video, we are going to look more into the task of JavaScript Engine. We will see what is JavaScript Runtime and learn about event loops. So, let's start. JavaScript Engine handles two most important things of the code: call stack and memory heap. Call stack will keep track of the order of code execution. It tells you where you are when running your application. It works as a LIFO methodology. It means it keeps adding the function when you are calling them, and the last function you called will released first. Memory heap is used to read or store data. All the variable assignment and logics come into this place. Let's look into an example. Here we have some code written in JavaScript. Now let's look how this all working. Here in the code, this driver and speed are variables, so they will get assigned in the memory heap. Then these functions, driver name and driving, also going to be allocated in the memory heap. Then the code execution starts. The first thing it adds in call stack is the global execution context. Global execution context is what wraps all this code together inside it. From that global context, we call this driving function. Now it will add this driving into the call stack. Now we call driver name function. So it will add driver name in the call stack. When the execution of this driver name function is complete, it will return the value and JavaScript Engine will remove that from the call stack. Now we come back in driving. When driving is finished, JavaScript Engine will remove it from the call stack as well. Now we only have global execution context in call stack, but we don't have anything else to do. So now we can finish the whole execution. JavaScript Engine will remove the global execution context from call stack, and our call stack will become empty. JavaScript Runtime. JavaScript is a single-threaded language. It means if JavaScript is doing something, then other functions have to wait until its first task is complete. Suppose you have a single landline in your home and someone in your family is already using it. So if you want to make a call, you have to wait until their call disconnected. Once they are done, then you can use the phone to make call. And once you are done, the phone is again available for use. The most common example of this is alert function. When alert is open, you cannot do anything on the web page. The complete browser will stop working until the alert is hidden. As we understand this from the call stack example, that at a time only one method is running. To tackle this issue, JavaScript Runtime comes in picture. It do this by using the web APIs, which are part of JavaScript engines. These web APIs do many things to improve JavaScript performance. For example, if you want to do some delay method which will execute the function after 5 seconds, you can use setTimeout. If you need some data from the API, you can use fetch. The main thing is these web APIs are asynchronous, so you can call them and continue working on other functions. The response from these web API will only come when call stack is empty. This will keep web APIs from forcefully returning something when JavaScript is doing some heavy work. There are many other things web APIs can do. We will have a separate video on most of them, so you don't have to worry about this right now. For now, let's see a simple example. Here we have this code which have a console log which prints A. Then we have one set timeout which will console log B after 1 second. Then we have another console.log which prints C. What do you think will happen if I execute this code? Here, set timeout will delay the internal function for defined time. It will wait for 1000 milliseconds or 1 second before printing B. Because of this, A and C printed first, but B is printed last, even when it's defined in between, because of this set timeout. Now, what will happen if I change this 1000 millisecond to 0? This means the set timeout will call the internal function immediately. What should be the output now? Let's run. You can see the output is still same. It printed A and C first before printing B. This happened because, as I mentioned earlier, Web API's response will only get added into call stack when call stack is empty. All this is handled by event loop. This event loop is a process which is constantly running in the background. It checks event queue and call stack to handle Web API responses. When a Web API completes its execution and try to return the response, this response first goes to event queue. Event loop will check if the call stack is empty and if there is anything in the event queue. If the event queue is not empty, then event loop will check the call stack. If call stack is not empty, then it means some execution is running in the memory. So event loop continue its works and check the call stack again. When call stack is empty, event loop will understand that all the other executions are done, so it can now get the response from event queue and add it in call stack. To visualize this, I found this awesome tool by Philip Roberts, which can show you how everything is working when you run a program. If I use the same code here, you can see it first executed the console.log statement. Then it execute this set timeout, but it didn't execute the inner function yet. It waited for the console.log C to execute first. After that, it added this callback from callback queue, or as we call it, event queue, to the call stack. If I change the timeout duration, you might understand it more clearly. You can play around with this site. I'll drop a link in the description. All of these we learned today are the part of JavaScript Runtime. These are all connected and actively working together to run JavaScript in our browser. That's all for this video. In this video, we talked more about JavaScript Engine and how they run JavaScript. We looked into JavaScript Runtime and Web APIs. We also understand event loops. I'll meet you guys soon in the next video. Check out my Facebook group for more tips and tricks and latest updates. That's all for now. Stay safe and stay productive.